Okay, so I'm going to take you through this ice problem actually using the book because I'm feeling kind of lazy and I've been doing this for a while now. So we are given an equation and we are also given the equilibrium constant. Okay, so it's equal to 5.1. And then we're told that the initial concentrations of everything is 1 mole per 1 liter. So everything is 1 molar. And so we are going to calculate a Q to see how the system would have to shift to reestablish an equilibrium. So if we go over here, this is in your book, by the way, page 597 and 596. If you look up at the top here, it calculates Q, and of course Q is 1 because the concentration of everything is 1. So Q was 1 and K, over here again, is 5. So Q is smaller than K, which means that we have too much on the bottom. So too much reactants. So we need to lose some reactants and we need to fix it by gaining some reactants. So how we write that, I'm going to look at this chart down here. We show that the reactants, so the CO, we lose some. Okay, the H2O is also a reactant and it needs to lose some, so we say lose X. And the CO2 is a product, so it gains some. And the H2O is a product, so it also needs to gain some. So the change is in the middle column here. And then at equilibrium, these would be the concentrations. So you see we have 1X, it's the same. If we lose it from the reactants, it has to go somewhere, so it's going to go to the products. So we substitute here at K, and it needs to equal the K, and we have those values that I just showed you with the change. And in this case it's an easy one because it's our first time looking at it, so it's a perfect square. So all we need to do is we take the square root, okay, and we get the square root of both sides, so 2.26 equals 1 plus X and 1 minus X. And from there we're going to multiply and collect terms. So basically this bottom we multiply by the 2.26 and then we combine the X, and when you do that you get that X must be 0.387 moles per liter. So the change is that the reactants need to lose that much, okay, so that their concentration becomes that, and the products need to gain that much so that their new concentration is that. And then it also does something nice here and has you check your answer. So when you substitute back in, look, there's K. Okay, so that is called an ice problem, where we have an initial concentration, we look at how it's going to have to shift, and then we determine what the change is, and we establish what it's going to need to be at equilibrium, and then we're solving for X. Okay, so I hope that gives you an introduction, and get ready because we got to dominate this. So, all right, bye.